All right, so let's give it a try this uh, video lecture, see how things go. Okay, so we are moving on to simplifying complex fractions, right? We're going to look at essentially two different methods to simplify complex fractions, right? Method one, which consists in simplifying numerator and denominator first, that is by solving essentially, well, actually simplifying two different expressions and putting everything together and simplify. Okay, I'm gonna explain what method two is gonna be after going a couple of examples on method one. Okay, so let's see. Let's look at an example here. So they're asking us to simplify the following complex fractions. Okay, number one, it would be a good idea to, okay, let's see. It would be a good idea to look at what a complex fraction is. So a complex fraction, notice how big and ugly they are, right? So essentially, a complex fraction is a huge fraction with many fractions inside of it, right? So this will be essentially the main division, right? So let's see. So we are going to have the numerator and the denominator to be simplified first, okay? Okay, so let's simplify numerator. Okay, to simplify the numerator, we do the following. Okay, let's write it down again. Okay, let me change color here. Let's change it to some blue here, maybe. Okay. So I'm gonna write x divided by y squared, which is the numerator, plus 1 over y. Okay, and I'm going to simplify this. So what are we going to do? Notice when trying to combine these two fractions together, there's no way we can just add these two because the denominator is not the same. So this is where we're going to apply the topic we did, the last topic we did in class, which is finding an LCD before we can combine the fractions together. So let's find out. Okay, so we have a y squared, we have a y, so it looks like multiplying and dividing by y will give us a common denominator. So we're going to have x divided by y squared plus y divided by y squared. Okay, so now mission accomplished. We have the two denominators the same, so we're ready to combine these two. Okay, so let's see. Write down a big fraction as we did in class and then keep the denominator because it's the same and only do the operation implied between the numerators, in this case, adding x with y. But because in this case there's no like terms to combine, we just leave it like this, okay? So we have the first thing now, simplifying the numerator. So now let's go ahead and do the same for the denominator. Simplify the denominator. And we're going to do the same as we can tell. As we can tell, we don't have the same denominator, right? If you observe the big denominator, which is y divided by x squared plus 1 over x. We are going to need a missing factor. So there's a missing factor of, in this case, x. Very similar to the numerator part, right? But in this case, well, let's see. Y divided by x squared plus 1 times x, which is x divided by x squared. Okay, so that's having the same denominator, so we're good to go and write this as a big fraction with the same denominator, x squared, right? And y plus x. In this case, what we're doing is doing whatever operation implied we have in the numerators of each fraction as we saw last time. Okay, so y plus x is the same as x plus y. I'm just going alphabetic order. Okay, I'm not really doing anything interesting other than just putting everything together. Okay, so mission accomplished with writing the numerator, right, instead of having 1 and 2 fractions as a single fraction, and likewise writing the two denominators of the big fraction as a huge fraction as well in a simplified way. So I'm going to use these two results and I'm going to take them here. Okay, so this is going to be equal to, we are going to open a big fraction, right? And I'm going to write this x plus y divided by y squared. And for the denominator, we're going to write x plus y as well, but in this case divided by x squared. Okay, how are we going to simplify this? Keep in mind the following. Keep in mind that when we have a big fraction divided by another big fraction, it would be a good idea to group. And we did an example like this when multiplying and dividing fractions, right? On section 6.1, in which we have a big fraction divided by a big fraction, as opposed to the other examples in which we have a huge rational expression, the division sign, and then the second fraction, the divisor in this case, right? And then we multiply by the reciprocal of the second fraction, or you might remember the KFC rule, right? So in this case, no need to write it as a division, right? As a division notation, we can just go ahead and multiply the denominator, multiply by the reciprocal of the denominator, which is really finding the reciprocal, right? So again, in a way, we are still using the KFC rule, right? So we are keeping the first fraction, the one in the denominator, flipping the fraction in the denominator, right? And this division, we are changing it into a multiplication. Oh, don't forget the square here. And turning the division into a multiplication. Okay, so at this point, this takes us back to an exercise from section 6.1, which is simplifying or multiplying rational expressions. What do I mean by that? Well, so we are going to observe what we have here so far, right? And we're going to look whether we have common factors to divide out. And it turns out, if you observe here, okay, let me use this color, we can divide out x plus y with x plus y, leaving us with the quotient between x squared and y squared. In other words, the numerator is left with an x squared and the denominator is left with a y squared. All right, and that's final answer. Let's call it a day for this example. Okay, let's move on to the next example. Let's see what we have. Okay, looks like we have something that looks a little bit ugly. Yes, it's big, it's huge, but again, let's do numerator first and denominator afterwards, one at a time, right? So let's see. And let's denote as usual. Let's write it down. Let's see. Simplify the numerator. Okay, simplify the numerator. Copy this down. Let's copy this down. However, notice the denominator of each individual fraction right here. They are not the same, so we are going to be in the need of finding a common denominator, at least common denominator. So what am I going to do here? I'm going to leave some space here to multiply by a missing factor. Oh, not 3. All right. So in this case, these two denominators, x plus 2, x minus 2, they are different. So let's multiply numerator and denominator of the first fraction by x plus 2 and x plus 2. Okay. And for the second fraction, we're going to have the following. X minus 2 otherwise, right? X minus 2. Okay, so observing the denominators of each fraction, we can see that we have the same denominators now. So at this point, we can go ahead and write a big fraction with the LCD in the denominator, x plus 2 times x minus 2, okay? And in the numerator, okay, I'm going to keep the colors, well, maybe not. So 1 times x plus 2 is just going to be x plus 2, right? Plus 1 times x minus 2. That's not going to change anything in the numerators, right? So x minus 2. So in the numerator, in this expression right here, so we are essentially, by the way, we are essentially done with combining the fractions together, right? So the next step is to simplify anything we can. What do I mean by that? Look for common, for like terms rather. Okay, so and notice something interesting here. Notice we have a positive 2 canceling with a negative 2. As opposed to having x plus x, which will give us a 2x. 2x divided by x plus 2 times x minus 2. Okay. So first goal accomplished, right? Mission accomplished for the first numerator, right? Let's simplify the denominator. Okay, denominator, right? Okay, denominator. Okay, so we are going to copy this sum below, which in this case is the denominator, right? So let's see. This is going to be 3 divided by x minus 2. I'm going to leave a space here for the missing factor. I think at this point you know where I'm going. And 3 divided by x plus 2. Okay, let's see what are we going to do. Missing factors. So for missing factors, I'm going to multiply the numerator and the denominator of the first fraction, in this case by the opposite, right, which is x plus 2. And for the second fraction, I'm going to do the same, right? I'm going to multiply and divide by the missing factor, but in this case, the missing factor is x minus 2. Okay, so at this point, we are ready to go ahead and write down a huge fraction with the LCD, which is x minus 2 times x plus 2. And let's go ahead and do the operations implied in the numerators of each individual fraction. Keep in mind right here, keep in mind that this 3 is multiplying, right, with x plus 2, and this 3 right there is multiplying with the x plus 2. Again, as I discussed in lecture when we were combining fractions together, I know what you're thinking here. You might want to do this in your head and just go ahead and do it in one shot. Okay, after a while, after some practice, if you feel comfortable doing that, go ahead and do it. But in the meantime, my advice is to write everything. Okay, so I'm going to write 3 times x plus 2 plus 3 times x minus 2. Okay. And the next step will be, before we can combine any like terms, use the distributive property, right? Use the distributive property, just the same way I'm doing it here. All right. And we're going to have 3x plus 6 plus 3x minus 6, okay? The whole thing divided by the LCD, which is x minus 2 times x plus 2, okay? Now, let's see. Let's look at the numerator and combine like terms whenever we can see. And notice how the positive 6 cancels this negative 6, right? So this will give us as a result, as a final result. Notice we can add this 3x plus 3x to give us a 6x. X minus 2 times divided by x minus 2 times x plus 2. Okay. Okay, let's go ahead and write this quantity right here where the numerator of this complex fraction is, right? Big fraction, x plus 2, x minus 2 under the quantity 2x. And for the denominator, the simplified version of it, which is 6x divided by x plus 2 times x minus 2. Okay. Now let's simplify this quotient of fractions, right? Again, keep in mind that we can group this, right? So we keep the first fraction, I mean the number in the numerator, right? Which is 2x divided by x plus 2 times x minus 2. And we multiply by the reciprocal of 6x divided by x plus 2 times x minus 2, which in this case is x plus 2 times x minus 2 divided by 6x. Okay, notice at this point we are ready to divide out common factors. Let's see. Notice how this x plus 2 divides out this x plus 2, right? The numerator and 1 in the denominator. Also, we have this x minus 2, canceling this x minus 2, all right? And finally, we have this, let's use a different color here. Let's use this shade of blue, why not? Cancel this x with this x, leaving us with the quantity 2 over 6, right? I could have prime factored the number 6, but let's keep it like this, 2 over 6, and then turn that into 1/3. Okay, and that's final answer. Okay, so that is a final answer to simplifying a complex fraction using method 1. Again, method 1 is by number 1. Okay, let's add numbers here, why not? This is step number 1 by simplifying the numerator. Step number 2 by simplifying the denominator. Once we get the two quantities together, let's do number 3, which is essentially write each numerator and denominator in simplified form and then turn this into a multiplication problem, divide out common factors, and simplify whenever possible. Okay, let's